Hello everyone, I hope you guys are doing good. So today we'll be discussing problem 191, number of 1 bits. So in this problem, we have to write a function that takes an unsigned integer and returns the number of 1 bits it has. So let's say, for example, we have an unsigned integer 0, 0, 1, 0, 1, 1. So for such cases, the only thing we have to do is to return the number of ones we had in an unsigned integer. So in this case, our output would be 3. So today, we would be discussing two ways or two approaches to solve this problem. The first approach to solve this problem would be using bit shift. So the main idea behind this approach would be to calculate the remainder of our given unsigned integer. Let's say we have an integer 0, 0, 1, 0, 0, 1. So what we would do is calculate the remainder of this unsigned integer. For this case, it would be 1. And we would keep a track. We would declare a variable count, and we would increment it if our remainder was 1. So we would have a remainder equal to 1 when we have a 1 in the last place. So in this case, we would have a 1. We would change our C from 0 to 1. And then we would right shift our unsigned integer by 1 position. So now a new n would be 0, 0, 0, 1, 0, 0. So as we can see, we did count one of the 1 bit and then right shifted and made a new variable n of unsigned integer. Now we would again calculate the remainder. As we can see, in this case, we had 0 in the last position. So we would not increment our count, but then we would right shift it and make it 0, 0, 0, 0, 1, 0. Again, we would follow the same thing. We would not count as the remainder was not 1 and right shift it. Now we have another 1, or I should say we would have a remainder equal to 1 in this case. And now we would count and increment our count by 1. And again right shift, and now we would have all zeros. So when we would reach the case when we would have all zeros, we would just stop and return our count. So let's talk about the coding of this approach. So first thing first, what we have to do is we have to keep a count, and we'll start our loop, and we would say while n is greater than 0, or I can just say while n, we would increment our count whenever the remainder is 1. So let's say whenever we have a remainder equal to 1, this would help us find if it's 1 or not. So for each case, we would just add the remainder. For the cases when we have remainder 0, our count will remain the same. Else, our count will increment by 1. And then we would right shift our unsigned integer by a single position. Finally, we would just return the count. So let's see a solution. As we can see, this is a pretty efficient solution, but I would also like to discuss another approach that would be using a logical AND operation of n and n minus 1. So the first thing you would be wondering is why am I considering a logical AND operation of n and n minus 1. Why n minus 1? So to explain this, I would like to take an example. So let's say we have an unsigned integer that is 0, 1, 0, 0, 1, 1, 0, 0. And what we have to do is first calculate n minus 1. And if you don't know how to calculate n minus 1 for an unsigned integer, what we only have to do is we have to find the rightmost 1 bit. In this case, it's this one. And we have to shift, or I should say switch, flip all of the 3 bits, including the rightmost one, till the end. So our n minus 1 would be 0, 1, 0, 0, 1, 0, 1, 1. And when we would perform an AND operation for this, it would just be 3 zeros at the end, and then a 1, 0, 0, 1, 0. And this would be a new n. So what we did, we just eliminated the last one we had. So by performing an AND operation between n and n minus 1, we eliminated the rightmost 1 bit. So for each such elimination, we would keep updating our count by 1. So after reaching this phase, we would again find the n minus 1. That would be 1, 1, 1, 0, 0, 0, 1, 0. And simply perform the AND operation again, and we would be left with 0, 0, 0, 0, 0, 0, 1, 0. So as you can see, now we only have a single 1 bit left over here, which would be eliminated if we perform another AND operation with its n minus 1. So now let's talk about the code, or let's discuss the code of our problem. So the only thing that changes over here is now, rather than checking for the remainders, what we are doing is performing the AND operation of n with n minus 1. And rather than changing or right-shifting our integer, an unsigned integer n, what we are doing is just updating our count by 1. So we would just keep a track of each AND operation and then return the count c, which would definitely be the number of AND operation we have performed. So let's check our solution. So as we can see, again, we have a good solution, performs well.